Alright, now we're going to develop the integral rules for trigonometric functions since they rely heavily on the concept of substitution. You should already know the integral rules for sine of x and cosine of x. The integral of sine of x is opposite of cosine of x, and the integral of cosine of x is sine of x. All the rest of the major trigonometric functions require us to use substitution in deriving their rules. Let's start with the integral of tangent of x. Well, since tangent is equal to sine of x over cosine of x, we can rewrite this integral as such, and then handle it using substitution. If we let u be equal to the cosine of x, since that's the function in the denominator, and then du is the opposite of the sine of x, dx. And so by substitution, this is equal to the opposite of the integral of du over u. And then we integrate. The antiderivative of du over u is the natural log of the absolute value of u. And then we will put cosine of x back in for u. And there's our integral of tangent of x. We're going to handle cotangent in exactly the same way. We're going to split it into the integral of cosine of x over sine of x. And then u is equal to sine of x. And du is equal to cosine of x dx. And so this turns into just the integral of du over u. And that's going to be the natural log of the absolute value of u plus c. Bringing u back, that's the natural log of the absolute value of the sine of x plus c. On a side note, we can represent the rule in A in a slightly different fashion. Remember that when we have a negative in front of the natural log, that's like raising what's inside the natural log to the negative first power. And so this is equivalent to this, and cosine of x to the negative 1 power is 1 over cosine of x, which is secant of x. So that's an alternate way that I can write that rule. But either one of those is fine with me. Alright. Now, when we find the integrals of secant of x and cosecant of x, it relies on a little bit of a trick here to develop the rule. We're going to multiply these by 1 in order to get them into a form that lends itself nicely to substitution. And the form of 1 that we're going to use in the first one is we're going to multiply this whole thing by secant of x plus tangent of x. I'm having trouble writing today. Over secant of x plus tangent of x. And that turns this into the integral of secant squared of x plus secant of x tangent of x all over secant of x plus tangent of x. Get my dx here. And now I'm going to handle this using substitution. And much like when I typically substitute, I want to substitute what's in the denominator. So u is equal to secant of x plus tangent of x. And if I make that substitution, then du, the derivative of secant, is secant of x tangent of x. The derivative of tangent is secant squared of x. I'll get my dx here. And you'll notice that this right here, come on, there we go. This right here is exactly the numerator. It's just the order of the addition is swapped. And so I'm going to replace all of that with a du, and this turns into integral of du over u. And then the antiderivative of that is going to be the natural log of the absolute value of u plus c. And then we bring u back, and there's our rule for the integral of secant of x. Cosecant of x I'm going to handle in a nearly identical fashion, only instead of multiplying by secant of x plus tangent of x over secant of x plus tangent of x, I'm going to do cosecant of x plus cotangent of x over cosecant of x plus cotangent of x. And that turns this into the integral of cosecant squared of x plus cosecant of x cotangent of x all over cosecant of x plus cotangent of x. And then my substitution that I'm going to make is going to be u equals cosecant of x plus cotangent of x. And then du, bring du down here a little bit. The derivative of cosecant is negative cosecant of x cotangent of x. And the derivative of cotangent is negative cosecant squared of x. Get my dx. And so when I make the substitution, you'll notice that what I have here for du is just the opposite of what I have here. So negative dx. And so I make my substitution for negative du. And so I'm going to replace that with a negative du, and that turns into the opposite of the integral of du over u. The integral of du over u is natural log of the absolute value of u plus c. And then I bring my u back. And there's the integral rule for cosecant of x. So that's where all of our integral rules for all of our various trig functions come from. Okay? Now, you should either know those rules or be able to come up with them quickly and easily like I did here. Okay? See you next time.